Alright, in this video we're going to talk a little bit about the real number system. And the real number system is basically the number system that you're used to, and you see, you're just used to it. So, there's certain ones that we're going to actually talk a little bit more about than usual. We're going to even talk a little bit earlier than this. So, the numbers that you're most used to are called natural numbers, and I'm going to put them on here, and they actually belong inside the inside circle here. So there's natural numbers. So the natural numbers, which are usually denoted by something like a little n thing here, those are the numbers you see in nature. And so the numbers you see, the counting numbers, like your fingers. So you start with 1, 2, 3, and they're natural numbers. Numbers you see in nature. So the natural numbers are the smallest circle that we've got here. There's not a whole lot in the natural numbers. There are an infinite number of natural numbers. This goes on as high as you can count, and then higher than that, and then higher than that. So there's no stop to the natural numbers, but they don't take us too far. You can add with natural numbers. If you add two natural numbers together, you'll get another natural number. You can multiply it. 2 times 3 is 6. You can't really subtract them. 2 minus 3 is the negative one, which is in one of these numbers. What's 3 minus 3? It's 0. So the next set is the whole numbers, which is a W. I forget where the little extra line is, but they're not all that surprising. It's 0 and then 1, 2, 3. So that's what the whole numbers are considered. So there's the naturals, and then I'm just put a W here and circle that out there. So there's only one extra number between the natural numbers and the whole numbers. I'm not really going to talk about these too much. I wanted to mention them because you've probably heard of them at some point in your life for school. So natural numbers, numbers in nature, whole numbers are numbers plus 0, and then we get to the ones we want to start talking about. So the integers. So the integers are the next set. So in integers, a lot of times people will account the integers coming with money. So you can add money together, but you could also be in debt. So integers, which are signified with a Z, which actually I believe comes from Zahlen, Z-A-H-L-E-N, which I looked up what it was last year, and it was interesting, but yeah, I can't remember anymore, so feel free to look it up all you want. So integers are the natural numbers and the whole numbers. So we have our natural numbers here, 1, 2, 3, so on and so forth. But you also have a 0, and then you have your negative numbers, negative 1, negative 2, negative 3. Most of the time, that's what we think of as the integers, as the numbers for most of us. It doesn't really take us through everything. So as the integers are here, we still have a whole bunch more circles. So what can you do with integers? You can add integers together. Negative 1 plus 1 is 0. You can add 2 integers, you'll always get an integer. You can multiply. You can subtract them. See if you can think about what you can't do with these that you can do with normal math. About 2 divided by 3. Is that an integer? It's not. That's what's called a rational number. So a rational number, which is Q for quotient. So a rational number is the next circle. So rational numbers are numbers like fractions. So like 2/3. But also 0, 1, because 1 can be written as 1 over 1. It could also be written as 5 over 5. So all of the whole numbers are rational numbers. All of the fractions are rational numbers. And same thing with decimals, like 0.5. That's 1/2. 2/3 is 0.6 repeating. 0.754, that's also a rational number. You can turn that to a fraction. So all ending decimals, all decimals that repeat, like 0.6 repeating, 66666 forever, so all rational numbers. And the same thing with all the whole numbers and everything. They're all in the rational set. So this rational circle goes around all of the natural numbers. So if you are a natural number, you are an integer. You are a whole number too. You're an integer, but you're also a rational number. What are the other circles? Okay, so if there's rational, the opposite of rational is irrational. Now, irrational doesn't have a fancy. So there's a Q. A lot of times I see people write I. Teachers going to write I. I've seen that a couple times. I don't know if that's the exactly right for irrational, but I'm happy with that. So irrational numbers. See if you can think of an irrational number. So what number doesn't fit? You can do almost everything with these numbers. You can multiply, you can divide, you can subtract, you can raise them with powers. One thing you can't do, you can't do the square root. Square root 2. Try typing that in your calculator. You get a really, really crazy decimal. It doesn't repeat. It doesn't stop. It goes on forever. In your calculator, if you type this in your calculator, it will stop because your screen only holds so many decimals. The square root of 2 has no pattern to it. You get like 874. You can't tell what that next number is until you see the next number. So irrational number is something like square root of 2, square root of 5. Not all square roots are irrational numbers though. What about square root of 4? That is 2, which actually fits all the way up here. It's a natural whole, everything, except for irrational. So irrationals are over here. So irrational numbers are completely separate from rational numbers. None of these numbers are irrational. They're all rational. Now, if you put the rational numbers and the irrational numbers together, that gives us the real number system, which is denoted by an R. So any number that you can think of fits in the real numbers. Now, in a little while, a couple years, you'll see more than even that. But as far as you're concerned, every number you've seen so far is a real number. Alright, so let's try class 5. So the first thing you have to do here is you have to simplify. So what's the square root of negative 64? Or square root of 64 with a negative out front. Well, square root of 64, this is kind of inside parentheses, that's 8. And you toss a negative, it's a negative 8. Is it an integer? Well, positive and negative whole numbers are integers, yes. If it's an integer, it's in the rational numbers. But think about this. You can't be rational and irrational at the same time. So the second that you check rational, you cannot check irrational. And if you check anything, you're checking a real number. Alright? That's a value. Makes things positive, right? So this is just the positive 8/3. Now, does that simplify? 9/3 is 3, but 8/3 does not simplify. So this is not an integer. Is it a rational number? Yep, because it's a fraction. Fractions are ratios. Ratio, fraction. Is it irrational? Well, if you say it's rational, it better not be irrational. Not if you checked anything, you check a real number. How about square root of 28? Well, I don't know what the square root of 28 is. The square root of 25 is 5, and I know the square root of 36 is 6, so it's an irrational number. Unless it comes out nicely, it's going to be a rational number. And the second you check something, you better check real. Let's try. I'm just going to go through the rest of these. So what's this? So negative 8 over 56. Well, 8 goes into 8 once. 8 goes into 56 7 times. So a lot of times people tell me that's negative 7. It's not. It's negative 1 7. 7 stays in the bottom. 8 goes into 8 once. 8 goes into 56 7 times. It's an integer. I said the negative, but no, it has to be a negative whole number. So, not an integer, is it a rational number? Yep, it's a fraction. And if it's rational, it can't be irrational. It's a real. That's 5, which is an integer, which is a rational number. Can't be an irrational, and it's real. This is 11, just like 5. It's got to be these 3. How about 2.4? First off, this is a negative 2.4, because the absolute value of a positive 2.4 is positive 2.4, and then you toss a negative symbol out. Integers do not have decimals, do not have fractions. So it's not an integer, it's a rational number. Rational numbers count all decimals and fractions. Can't be rational, it's got to be real. Alright, last couple here. So, 4 over 25. I can't do 4 over 25. It's not, but the square root of 4 is 2. The square root of 25 is 5. Okay. Is that an integer? No, not a whole number. Is it a rational number? Yep, it's a fraction. Rational? No, not real. And this last one, almost a trig. So here's the thing, I don't know what that is in my head. So what we gotta do is we gotta go to our fancy calculator and type that in and see if we get anything nice out of it. So we're gonna clear this off. And second square root, if you haven't seen it yet, is right here. See it's second, and then this, that brings us the blue square root. And we type in the number, 3.68239. Now my gut would tell me that's an irrational number, but let's see what happens when I press enter. Now, it's actually kind of hard to tell. I can't tell if this is stopping or not, but if you look up here, this is how many decimal places the calculator goes. Because here's the thing, if I square like 1.256 and I square that, I get this number. And then if I hit the square root of that number, I get my 1.256. So either this is a really long number that does stop, but I don't think it is. This number would have to be an irrational number. Make sure that you type it in right, 239. So my gut was there was a rational number, and my calculator seems to back that up, even though I can't see what happens after here. You might argue, oh, let's go 5544, is it going to go 55 and then 44? I really don't think so. So I'm going to put an irrational number. But the second I do that, it is a real number as well. Alright, in this section we got to determine if the statements below are always true, sometimes true, or never true. And we got to justify our answer. Alright, so if you multiply an integer by an irrational number, then the answer is classified as irrational. Okay, so let's see if that's always true or not. So first things first, try one. Let's try 3 times an irrational number, so it's square root of 2. Now, if you're not so sure, you can always try that in your calculator, or here, even easier, an integer. 1's an integer, right? 1 times the square root of 2 is square root of 2. So it's definitely at least sometimes true, because integer times the irrational number is irrational. Now here's the one that's a little sneaky. 0 is the integer that you have to watch out for a lot. 0 times the square root of 2. That's 0. That's not an irrational number. 0 is very rational. It's nice, whole, neat, no problems. So, is it always true? No. Is it never true? No. So it's sometimes true. Alright, what about example 4? If you're multiplying an integer by an integer, you will always get an integer. Alright, well, let's try a couple. 2 times negative 3. That gives me negative 6, which is an integer. Remember, no fractions, no decimals. And how about our 0? 0 times negative 3, that gives me a 0. Now, it's really sometimes kind of tricky to even like, because we haven't tried all the integers, right? It's not proof. I'm not going to try to ask you to prove it. That wouldn't be a bad problem for like a college class. Or for us, we want you to just think about it. Is there any other way you could get like a square root out of multiplying or a fraction out of multiplying? Yeah, I'm hoping the answer in your head is no. So this is always true. Alright, I'll leave the rest to you. Good luck and have fun.